discussion of some principal problems of modern cosmology and astrophysics. Corresponding results were obtained, published in a number of our papers in classical quantum gravity, physics letters R, physics letters B, Journal of Cosmology and Subatomic Physics, Modern Physics R, and others. Because I am for the first case at Vigier symposium, I'd like to present the most important ideas and results obtained in our previous papers, and then discuss new results which are not published. What problems will be discussed in my talk? The base of modern cosmology and astrophysics and gravitation theory is general relativity theory by Einstein. According to general relativity theory, physical space-time has a structure of Riemannian continuity, and metric properties determine various phenomena in cosmology and astrophysics. And in non-relativistic approximation, general relativity leads to gravitation, to Newton's gravitation law of gravitational attraction. However, in the frame of general relativity theory, the gravitational interaction has the character of gravitational interaction has the character of attraction also at extreme conditions when energy density and pressure are extremely high. It follows from Riemannian cosmological equations. And as a result, the cosmological singularity, the state of cosmological singularity appears at the beginning of cosmological models. This leads to the problem of the beginning of the universe in time. This is problem of appearing of singular state also in the case of black holes. The appearing of singular state with when energy density is infinitely high means that gravitation theory by Einstein is not applicable in this situation.
Go to slideshow.
Slideshow.
Go to slideshow.
How to start it?
Slideshow.
Right at the bottom. Right there.
Yeah, where did that?
Up. Yes.
Click on that.
Click.
And then
From beginning.
From beginning.
This one.
Thank you. The second problem, cosmological problem, which will be discussed, and problem cosmological and astrophysical, is the problem of invisibly matter components. In order to explain cosmological and astrophysical phenomena, it is necessary to suppose that the most part of matter in our universe is connected with dark energy and dark matter. And only 4–5% energy is connected with ordinary periodic matter. Now, in order to resolve these problems, many attempts were made in the frame of general relativity theory and general alternative theories of gravitation. Radical ideas connected with the notions, strings, extra dimensions, M theory were considered with the purpose to solve the problem of cosmological singularity. Various kinds of matter were introduced to explain phenomena, introduction of which exists these components. I'd like to know that the most part of alternative gravitation theory are based on ad hoc introduced hypotheses and don't have solid theoretical foundations. At the same time, there is the gravitation theory which is based on generally accepted physical principles, including the principle of local gauge invariance. The construction, the metric gravitation theory and general relativity theory is a particular case of metric theory, can be introduced on the basis of local gauge invariance principle by considering the four-dimensional translation groups as gauge group which corresponds to gravitational interaction. However, by including the Lorentz group into the gauge group which correspond to gravitational interaction, we obtain with necessity the gravitation theory in the Riemann-Cartan space-time. The simplest gauge theory in the Riemann-Cartan space-time is Einstein-Cartan theory, which is based in gravitational interaction in the form of scalar curvature of Riemann-Cartan space-time. This theory was investigated in a number of papers of Kegel, Ivanenko, Shama, and Polish physicist Andrzej Trautmann with However, in the frame of Einstein-Cartan theory, the torsion is connected with spin momentum gravitating matter by a linear way. And in the case of spinless matter, the torsion vanishes. In connection with this, in literature, is opinion that the torsion is connected only with spin. In the case of spinless matter, vanishes. However, the situation is other if we take into account that in the frame of gauge theory, the gravitational Lagrangian usually is given as function quadratic in field strength. In our case, the role of gravitational field strength play the curvature and torsion tensor. However, in our case, exist many invariants quadratic in the curvature and torsion tensor. In connection with this, by construction of gauge theory of gravitation in Riemann-Cartan space-time, because we don't know exact form of gravitational Lagrangian, the gravitation theory based on gravitational Lagrangian in general form given here was investigated. here a number of indefinite parameters, Fe and Re, we have a number of parameters. In the case of minimal calculum gravitation with matter, the role of gravitational, of source of gravitational field play the energy momentum and spin momentum of gravitating wave. And in general form, gravitational equations is given, and these equations were investigated, and isotropic cosmology was built and investigated in the frame of general theory based on given Lagrangian. And in my paper published, no, I'd like to note the most important characteristics concerning isotropic cosmology. Matrix is given in the form of Robertson-Walker metric. R is scale factor, and in the case of specially homogeneous isotropic models, the torsion tensor has only what the following components, which don't vanish, and two torsion functions appears, S1, S2. S1 has the character of scalar function, and S2 pseudo-scalar function. And equations in general form of isotropic cosmology were obtained and investigated. This equation includes 5 indefinite parameters, and in order to find exact expression of gravitational Lagrangian, we have to find restriction of this parameter from what conditions. This theory has to satisfy the correspondence principle of general relativity theory with Riemann and cosmology, and allows to solve principal problems of general relativity, in this case, in the framework of isotropic cosmology. And the analysis of obtained equations shows that the most important physical results can be obtained if two restrictions are introduced for indefinite parameters. R, it is equal to 0, and epsilon parameter S vanishes. This means that cosmological equations and equations for torsion functions of isotropic cosmology include 3 indefinite parameters. And here are presented cosmological equations, which are generalization of Friedman cosmological equations, and equations for torsion functions have the following form. I'd like to note that because parameter B omega indefinite parameters have to conditions omega is omega is positive and very and small, and parameter B is up and F zeros are very close. As a result, the fact that cosmological equations contain x in degree 1 through 2, we obtain from conditions that x cannot be negative, the conclusion that our equations, cosmological equations, lead to appearance of limited energy density. This limited energy density can be found from condition x is equal to 0. And the order of limited energy density is given here. The analysis of our equation shows that in the case of usual gravitating matter with positive values of energy density and pressure, all cosmological solutions are regular with respect to matter, its derivative, and also with respect to torsion functions and curvature functions. This means that this theory leads, instead of Big Bang, we have models of big bounds. All cosmological solutions can be continued and don't have the beginning in time. This means that this theory allows to solve the problem of cosmological singularity. At asymptotics, by taking into account restrictions on indefinite parameters, cosmological equations at asymptotics take the form of Friedmann cosmological equations with effective cosmological constant. S function, curvature function S bar is also present here. I like to note that cosmological constant, effective cosmological constant, appears as a result of exact solution of gravitational equations of isotropic cosmology. And the appearance of this effective cosmological constant is connected with the fact that, as was shown in our paper, the physical space-time in the vacuum has a structure of Riemann Cartan continuum with de Sitter matrix and non-vanishing torsion, but not Minkowski space-time. Command this conclusion was obtained. We suppose as physics, when matter decreases, energy density and pressure tend to 0, we obtain the solution, the vacuum, and the structure of the vacuum by supposing that the vacuum is the structure of the vacuum is homogeneous isotropic, special. Its structure can be obtained from our cosmological equations. And namely, this analysis shows that physical space-time in the vacuum, in the frame of this theory, has the torsion. Namely, the torsion S1. By virtue of this torsion, effective cosmological constant is induced in the cosmological equations. Appearance of cosmological constant means that gravitational interaction has the character of repulsion, but not attraction. Not only at extreme conditions near limited energy density, but also when energy density is very small and comparable with energy density of matter in our present epoch. By using these conditions, that our cosmological constant corresponds to acceleration of observable acceleration of cosmological expansion, we obtain the connection between two indefinite parameters, alpha alpha has in the dimension of inverse energy density, and beta. And as a result, what the vacuum value of torsion of function S2 is given here, and by the curvature tense can be expressed by means of curvature torsion tensors and non-vanishing components of curvature tensor is expressed here and are connected with torsion functions S2. We see that in the frame of cosmology, in the frame of our theory, the problem of cosmological singularity and the problem of dark energy can be solved in the frame of standard lambda C-D model. There is a problem of cosmological singularity because if cosmological constant is interpretation of this cosmological constant is the following: this constant is connected with the vacuum with the energy of quantum fields vacuum. There is problem. In our case, only without this problem, ponieważ in our case, cosmological constant is expressed by widths independent parameters, and its value gives restriction on this parameter. The following equation appears if in the frame of gravitation theory, in Riemann-Cartan space-time, we can solve principal problems of cosmology. What role of torsion in astrophysics takes place? In general case, the consideration analysis of this problem is difficult because of, in general case, in our Lagrangian, gravitational equation, general case, are very complicated. However, the analysis of this theory shows that in the frame of this theory, in order that tachyon and the analysis of particle content, this theory will positive. We can use as gravitation theory the following gravitation Lagrangian gravitation theory, and this restrictions this parameter are given. This theory depends on three parameters which appear in relativistic isotropic cosmology. And by using these conditions where for parameter beta, for parameter omega, gravitational equations of this theory named minimum gravitational theory. Here, equations, gravitational equations. This equation leads, in the case of spinless method, to Einstein gravitation equations is by supposing the energy density, values of energy density, are very less than limited energy density. These equations were obtained by if terms with small parameter omega, which plays principal role at extreme conditions with these terms are not essential. And in this case, the role of vacuum torsion in astrophysics, possible role, was investigated. Vacuum torsion is created, vacuum torsion, which was introduced in the frame of isotropic cosmology, is connected with torsion created by spinless matter. However, if we take in account that astrophysical objects, planets, stars, galaxies, possess own moment, which is spin moment. In astrophysics, moment, rotational moment, is considered as spin moment. And in this case, the influence of torsion, of vacuum torsion, on movement of objects which possess proper own spin moment. Equations. This equation were obtained in our paper published in 1975 with Professor Sokolsky. And this equation are presented here. Equations of motion, translational motion, equations of rotational motion, where mu is generalized moment, which and omega mu is tensor of which for angular velocity, components of angular velocity are connected with this tensor. And in our case, these equations are in non-relativistic approximation are simplified, and vacuum torsion can play the role in the case of motion in non-relativistic approximation. Here, what equation of translational motion and equation for vector omega. This omega is connected, generalized omega. This omega is vector of angular velocity. This vector is connected with angular velocity and also dependent on vector velocity. And the analysis of this equation shows that the force, in our case, in non-relativistic approximations, is equal to sum of Newtonian force, the first step is Newtonian force, and additional force appears. The value of this force depends on the value of vacuum torsion as to vacuum. And results, I'd like to note that by taking into account the value of cosmological constant, which gives observable acceleration of cosmological expansion, we can obtain for vacuum torsion this where x dimensionless parameter and result analysis of stars, of this movement of stars in galaxies, of galaxies in clusters of galaxies, depend essentially on value of vacuum torsion. And as numerical analysis shows, for example, in the case of a star similar to our sun, which gives in a galaxy similar to Andromeda, by using corresponding parameters, if x is equal to 10 in degree minus 25, no, we can explain rotational chaos in galaxies. Of course, this conclusion exiges the analysis, and it is necessary numerical analysis by different values of vacuum torsion. And according to rotational equations for rotational motions, the plane where for trajectory, the plane changes with the time, and the analysis, of course, of in astrophysics, the analysis of the role of vacuum torsion in the motion of planets, stars, and galaxies, and cluster of galaxies. For this, we have made numerical analysis, and this is future work. We obtain what is gravitational interaction at cosmological and astrophysical scales depends on structure of physical space-time, namely of its torsion, that allows to solve some principal problems of general relativity theory. Namely, the problem of cosmological singularity and the problem of dark energy. We can explain the acceleration of cosmological expansion without using the notion of dark energy. And the gravitational interaction has a character of repulsion because the structure of physical space-time in the vacuum has more complicated. It is not Minkowski space-time. It is space-time of structure of Riemann-Cartan continuum with non-vanishing torsion. And this torsion plays an important role in astrophysics. And in cosmology, also S2 torsion plays the principal role because the expression of S2 includes the expression of torsion, what includes such expression. The results concerning cosmological results were obtained in my early papers and were presented in a number of conferences, Russian conferences, Marcel Grossman conferences, and others. But results connected with astrophysical consequences of this theory are not published. And no, if we have to investigations made in the frame of this theory. Thank you.
minutes for questions.
Thank you for your talk. I have understood that from the cosmic background, people have seen that the space or in cosmology is actually flat. Is that in contradiction with it having no torsion or with torsion, or is there no contradiction? Can it still have torsion but while being flat? That's the question.
Space-time, I'd like to in the frame of the theory, different solutions exist. In particular, it was shown early that in the case of spherically symmetric systems, Schwarzschild solution with their torsion is exact solution independently on restrictions on indefinite parameters. In connection with this, various papers where the theorem, Birkhoff theorem, was considered, were investigated. However, from the point of view obtained results, these solutions are not physical because we have the physical, from physical point of view, such solutions are important, which leads to asymptotics, to vacuum, which has the structure of Riemann Cartan continuum. This problem was discussed in my paper, which was
That is not really my question.
But in my paper, 3, this question was analyzed, and which in the frame of this theory, there are many solutions which are, from physical point of view, is.
Yes, I realize, but I'm referring to an experiment which may or may not be right, because the interpretation of that experiment is always a matter of discussion, and from that you see that on the large scale the space is flat. And my question is whether or not that is in contradiction with torsion. So flat means it's not curved, but it doesn't necessarily mean that it can't have any torsion. Maybe, but that's actually the question that I'm asking.
What role of torsion? I'd like to know that in the case, when the influence of torsion on rotation case was found in a galaxy, by this value of torsion, this influence in solar systems is negligibly small, because the value, velocity depends on distance, and by these distances, astrophysical in galaxy, in clusters of galaxy, this expression is important. The influence of torsion is important. But in solar,
I see your point. But this is why I asked the question. So, but we can discuss it later. Thank you. Thank you.
Thank you. Can we applaud Albert once more? Thank you. Does anyone